My name is Bob Finn. I'm with UEI, and today's webinar will be covering UEI's edge computing and IoT. This is meant to be a somewhat informal briefing and Q&A session to cover various concepts. As you can see, we'll discuss solutions using programmable automation controllers that fill the role of an IoT edge computer, giving you the ability to monitor, control, and gather data in your IoT system. Please enter whatever questions you might have using the chat box on the lower right-hand side of the page. On hand will be your resources, the UEI Applications Engineering team. They are Timur, who wants everyone to live dangerously by using AutoSet on your oscilloscopes. Austin, he's an application engineer with 5+ years in the data acquisition industry, expertise with embedded devices, hardware and software aspects. He's also an avid hiker and a bad flight simulator pilot. Phil agrees with Brian. Knowledge starts with the first question, which leads me to Brian. Brian is the type of guy who, when you send in the questions, he always has the answers. And finally, Prabhu. On the other side of the pond in the UK, he has really nothing to offer but solutions, workarounds, and fixes. His mantra, keep calm and carry on. So that's our team today. And Austin will be reviewing the concepts. So take it away, Austin.
All right, thank you. So as Bob mentioned, my name is Austin Turner, and I'm an application engineer here at UEI. Just a quick introduction to today's masterclass. We're going to be talking about IoT, which is the Internet of Things. So IoT is a rapidly growing field. And really what we're seeing now is a proliferation of smart devices, whether it be Google Nest, Amazon Alexa, smartwatches, and a lot of smart devices, smart bulbs, smart refrigerators, all of those devices. It almost seems like we can prefix any word with smart and it becomes an IoT device. But today, what we're going to focus on is the industrial side of this. And that's sometimes referred to as IoT, or the industrial Internet of Things. So we're talking about sensors. Could be vibration, could be thermocouples, could be devices that are communicating over different protocols, such as serial, RS-232, 485, CAN bus, or we can throw in some avionics, like ARINC 429. And so we're getting all that data, and then we're sending it to some database, which could be cloud-based, lending itself to IoT. We're going to change up the agenda a little bit today. We're going to review 2 videos about UEI and IoT, and then I want to give a demo. I have my fingers crossed that everything works out well, because we've set this up very recently, but we're going to give that a try and show how UEI is ready to roll in IoT applications right from the start. So without further ado, let's step into some of the IoT videos.
In a typical Internet of Things system, you have embedded sensors and controllers at one end gathering and sending data, and cloud computers at the other end processing the data. Linking these two parts lies a crucial component called the gateway. Here at United Electronic Industries, we manufacture programmable automation controllers which excel at filling the role of an IoT gateway. For starters, our hardware works with a number of interface protocols common to IoT, including MQTT, OPC UA, and Helix. UEI offers a wide variety of input options to choose from, as well as options to send the data to the cloud any way you want. Additionally, customers can take advantage of the onboard edge computing to optimize the raw data, and built-in encryption to keep that data secure and protect your valuable IoT investments. Our autonomous products are designed to be easy to deploy, compact enough to embed almost anywhere, and built to withstand extreme environments. We also offer a 10-year availability guarantee covered by a 3-year warranty on all our products. This is why BAE Systems turned to UEI for their new hybrid propulsion system. Installed on buses in operation all over the world, the discrete UEI hardware collects data during the day and automatically uploads it to BAE's bus fleet health monitoring network at night. The data is then compiled, analyzed, and converted to actionable intelligence for network subscribers. And that same versatile hardware used by BAE is also being used by customers for applications on land, under the sea, in the air, and even in space. So, need to gather data from your expensive capital equipment and securely send it to the cloud? Looking to utilize AI and machine learning algorithms to make predictions and proactively manage your assets? Want a rugged, reliable system capable of operating in any kind of environment? When you need a proven, flexible data acquisition and control solution for your IoT system, you need UEI.
Okay, so that concludes the first video. Let's jump into the next video here. This is going to go into MQTT and some demo code that comes with our UEI pack.
The UEI pack, UEI's Programmable Automation Controller, is an embedded Linux controller that comes pre-installed with Eclipse Mosquito, an MQTT server. The Mosquito service can be used as a publisher, a subscriber, and/or a broker. Let's look at an example of the Mosquito service being used as a broker and a publisher. First, I add a Mosquito user, and then start the Mosquito service. Next, I start the example code that is installed on the UEI pack. Here I'm running device 0, an analog input with 8 channels at a frequency of 10 Hz. In a separate terminal, I can use the Mosquito service to subscribe to the data. The tags are defined as the following, with the hashtag being a wildcard to accept all channels. And here is the data read from our analog input. Starting from our example code, you can easily create your own IoT application. When partnered with a cloud service, IoT presents a powerful way to visualize data from anywhere in the world. This covers getting started with UEI and IoT. You can learn more about this topic in a white paper entitled Internet of Things and UEI Data Acquisition and Control Systems, which you can find on our website. And as always, if you have any questions about IoT or any UEI hardware, you can contact our support staff directly, by phone, by email, or through our website.
So what I have here is a terminal open on our UEI pack, which is our embedded Linux controller. So we can do typical Linux commands. And what I want to demonstrate here is just one thought of an application for an IoT system. So if we imagine a scenario where we're monitoring maybe a temperature, maybe a motor, and we want to send an alarm when maybe that RPM is too high or that temperature is too high. One way to send that alarm would be to send an email. Now, I could just run that script, send the email, and show you an email. But however, I don't want there to be any thoughts of funny business where I fake this at all. So what we're going to do for real is get the actual time of day and embed that in the email. So what I've done is I've written a script to grab the time from an MTP server. So we can see that time is the current UTC time. What I'll do next is I'll append that to the file that I'm sending. So what that's done is I have some text in that file, and that's going to add it to the end of the file. So we'll know that this email actually came in, as soon as I've sent it. And now I have a script here that's sending that email. So the way that this is working on the UEIPAC is I've cross-compiled the curl utility from Linux. And curl allows you to send emails and a bunch of other file kind of network I/O through that utility. So we'll see that sends. We'll give that just a moment. We'll take a look at that email. And again, this is just one way of getting your data over the network from an IoT perspective from the internet. So we can see this is from me. I did our dev table, device table command, so I can see the boards that are inside the chassis. So I have a CAN bus 503, an analog input, digital input, and then another analog input. And we can see precise time of day. So that was sent directly when I ran that script. Another demo to show is publishing data using MQTT. So we have code that works right out of the box. It'll run with inputs, and it'll collect data from those inputs and publish it to a cloud service. So what I've done is I've modified the code a little bit to send some outputs and wire that back to inputs. So we'll run that IoT demo. And we'll see once it's started. We'll get some publish commands. We'll get some pushback. That means it was received by the MQTT broker. And let's see here. So in my Windows terminal, I've written a Python script. Let's see if I can remember what the name was. Of course, Python MQTT demo. And now I'm connecting to that MQTT broker. So I'm not necessarily connecting to the UEIPAC itself, but rather reading data that it's publishing to the broker. So we can see, it's going fairly quickly, but I have analog inputs, I have digital, and I have CAN bus data all coming through. So let's go to the first round of questions that have come in. And let's see what we have. So one of the questions that came in, what is MQTT? So MQTT stands for Message Queuing Telemetry Transport. And really what it is a publish, subscribe, or pub sub protocol. And the power of that pub sub protocol comes from using a broker, which is typically a cloud service. So in the case of the demo I just showed, our client, the UEIPAC, is publishing data to the cloud broker. And now any number of clients can subscribe to that broker. So that's really easing the network traffic away from our edge IoT device, which is typically low power, low CPU usage as well. And all the heavy lifting, all the heavy network traffic is handled by the broker within the cloud itself. Another question, how do I encrypt my data? This really depends on how you're sending the data. So MQTT at the application level uses TLS, which is the transport layer security. So with TLS, you can have message authentication with username and password, and you can also encrypt the data. There's plenty of other methods of data transfer that might fall in the category of IPsec, or IP security, and that operates at a lower level than TLS, where TLS is application level. Let's see, next question. How easy is it to run Python on the pack? So with our PowerPC pack, which is what I showed here, you would need to cross-compile Python and run it on the pack. That's not difficult, and we can help you. We've cross-compiled Python for the pack in the past. Our next generation CPU, which is our ARM processor, or sometimes called our Solo-X, uses a Solo-X ARM CPU, will come pre-installed with Python. So running Python on our next gen processor will be as easy as just typing Python and writing your script and running your Python script. What data rates or scan rates can be achieved? This depends on really what you're looking to do on the UEI pack. So if you're just publishing data, then I think a safe bet would be right around 10 kilohertz, where you're sending buffers of data rather than a single point 10 kilohertz worth of packets. That would definitely load down the CPU. Instead, what you might want to try is, since we're an embedded Linux controller, is you can write that data to a file and then send that file periodically to the cloud. That's going to limit the network traffic that you have to use. And it doesn't allow you to view the data real time, but it'll give you higher throughput of actually collecting data, maybe some processing on the UEI pack itself. Question, does electrical noise affect IoT? That's a good question. It depends on how you're looking at electrical noise affecting it. Certainly if we're over wireless communication, electrical noise can affect wireless connectivity. From the sensor side, for our analog inputs, we provide many utilities part of each analog input that helps to mitigate the noise from the sensor itself. Another question, how reliable is the wireless communication protocol? So that just depends, again. So for wireless communication, depends on which protocol you're using. And then it depends on the environment that you're in. So reliability will vary greatly whether you're surrounded by trees or in the wide open, with clear line of sight of what you're trying to connect to. Let's see. Is the data timestamped on DAC device or once it reaches the cloud? So that's a great question. I can't speak for the cloud service. The one I'm using is a free trial cloud, MQTT.com. So I don't know if they timestamp the data, but we can certainly timestamp it locally. Now, you might want to review a previous masterclass we had about synchronization techniques, because that timestamp, you would most likely want a time of day timestamp on each data sample. Now, you could use NTP, like I used in my example, or you might want to use GPS. Can MQTT be used for closed-loop applications? I would say it can and it can't. So MQTT will definitely have some overhead, some delay, where you're sending this data to a broker, and then another client has to subscribe to that data. So there's going to be some amount of latency, which you don't want typically in closed-loop applications, or at least if there is latency, you want it well-defined and deterministic. Now, MQTT can be used in conjunction with closed loop applications. So again, if we're looking at our UEI pack, we could be running an application that's controlling that closed loop application. But then we're also publishing maybe a current state to a broker. That way, the closed loop application is running in its own deterministic way, but there's a separate maybe thread or separate process that's handling all the MQTT traffic. Okay, those were great questions. Let's go forward to the next video, and we're going to take a look at Vistas. So we'll take a look at the Vistas protocol, a quick demonstration, and then we'll try to go over some questions about Vistas, and then also cover what is Vistas.
UEI and Vistas are a perfect match. As you can see in this demonstration, we have an inertial reference unit sending data via ARINC 429 to one of our two UEIPAC cubes. A function generator producing a sine wave is also sending a signal to the input cube. The UEIPAC input cube packages the data from both sources into Vistas packets and sends it along to a second UEIPAC. This cube converts the Vistas packets back into ARINC and analog data. In this demonstration, the ARINC message is output to a multifunction display in real time. Additionally, a PC connected to this network subscribes to the Vistas data and displays not only the inertial reference data, but also the function generator sine wave. The UEIPAC is flexible and can even be used to simulate avionics instruments. This allows for rapid testing where non-existing hardware, such as an inertial reference, can be simulated. The real hardware can be swapped in at any time without any changes of the wiring. Also, existing equipment can be shared remotely, making distance a non-factor. Integration tests can now begin much sooner with equipment distributed throughout the network. Pairing the UEIPAC hardware with Vistas provides a compact, flexible, and simple way to virtualize avionics testing that removes the need for expensive equipment and cabling, saving time and reducing costs.
So one of the first questions that came in that I should have gone over prior to that video is, what is Vistas? So Vistas is the virtual interoperable simulation for tests of avionics systems. Quite a mouthful, so that's why we'll just refer to it as Vistas. It's a newer protocol that was originally developed by Airbus. And as the name suggests, it's a way to virtualize avionics systems. So this could be avionic devices, such as the inertial reference, which was mentioned in that video, or really any device. It could be synchros, resolvers, could be push buttons, and so on. But it's really based for those avionics expensive devices. That way you can have, we'll use UEI as our example. You can have one UEI cube that's reading that expensive avionics device, and then sending that out over the network. Because Vistas is a network-based protocol. It's based on UDP, multicasting packets, which allows multiple receivers to receive the data all from a single transmitter. It wasn't built with IoT in mind, but its implementation can be adapted to work over vast distances, which lends itself to IoT applications. So let's go over any more questions that are coming in. Question came in. Do you support OPC UA? Yes. So we only mentioned it in that first video. So first off, for those that don't know, OPC UA stands for Open Platform Communications Unified Architecture. Really, the benefit of using OPC UA is that it's an industry standard. So it plays well with interoperability. It also has built-in security features, and you can map other industrial protocols to OPC UA format. So you can have Modbus that's converted to an OPC UA format. I'm not aware of many cloud services that support OPC UA, other than the Microsoft Azure IoT cloud. And actually, Microsoft put a fair amount of work into the OPC UA standard to help support IoT applications. So that was one of their big pushes with the Azure IoT cloud. Let's see, question. Are there licensing issues with Vistas? That's a great question. I actually don't know the answer. So I'll write that down and I'll make sure we get back to you on that. Okay, so I don't see any more questions right now. So let's go into the last part. Oh, let's see. One question that come in. Can we say Vistas is a specialized version of MQTT? I wouldn't say it is because they're really different. MQTT, the power comes from that broker, whereas Vistas is multicasting to multiple receivers. MQTT, again, it's pub sub, so you have a publisher and multiple subscribers, which is a little similar, but again, the MQTT broker really differentiates Vistas and MQTT. There's a lot of different intricacies of Vistas as well. It's really based for avionics, where MQTT was really based for pub sub of IoT applications. All right, so let's jump into the last part of the agenda, which is really just kind of a quick idea of where an IoT application could be used. So there's something called health usage and monitoring, or HUMS. Now, not every HUMS application lends itself to being an IoT application. For example, UEI was recently put into UH-1N helicopters for HUMS applications, and you really wouldn't want to broadcast that or store that data, in some type of cloud database. It's really for local health diagnostics. But if we look down here and we go back to that original video, the BAE buses, and so what we're doing there is we're tracking the health of the BAE buses. So we're monitoring the CAN bus, all those messages coming over the CAN bus, and then sending that data to their database. So we can think of the idea of big data. They're processing all that data and checking the health of their buses, keeping those buses online for longer, which of course is great for them and great for users of the BAE buses. Now, one of the benefits of using UEI is something we call our guardian features. I'm not going to go into too much detail about that right now. Actually, our next webinar is going to dive deeper into guardian features, so feel free to join us for that. But what the guardian features do is give us extra diagnostics. So rather than just a digital input, we're also monitoring voltage. Instead of just monitoring, RPM of a motor through a Hall effect sensor, we're also detecting open and short circuits in that sensor. So again, it's this extra information that really lends itself to HUMS applications and HUMS applications that work through IoT. All right, so let's open up for any final questions. I'll give another a minute here and see if any last questions come in. Okay, thank you all for being a part of this masterclass. I hope you learned as much as I did when I researched this topic. Again, thank you, and I'll turn it over to Bob now.
All right, thank you, Austin. I'll just say thank you so much. That was a great webinar. Thank everyone else for participating. We'll be contacting anyone with unanswered or partially answered questions, and if you have any more questions or need support, please email us at support@ueidac.com or just call us. And we'll be continuing the masterclass series at the same time next Thursday. And as a reminder, May is Avionics Month, so we'll be back covering MIL Standard 1553 and ARINC 429. And until then, please stay healthy.